Hi, everybody. Today I want to address something that a lot of people are afraid of, and that is the properties of equality and the properties of inequality in algebra. And the reason that they seem so weird is that they seem terribly abstract. So what I'd like to do is present you with a method for seeing them visually or imagining them visually. I wish I could do this at the beach. Unfortunately, I didn't think of it, and I'm no longer able to head down to the beach. So I'm just going to have to pretend that I've got piles of sand here. So what I want you to do is I want you to imagine I've got two piles of sand here. And what I'm going to do is they're equal piles. That's why there's a little equal sign between them. And what I'm going to do is I'm going to take two shovelfuls of sand off of this side over here. And I'm also going to take two shovelfuls of sand off of this side from each of those piles. And if they were equal piles to begin with, then they remain equal piles. That is the subtraction property of equality. And it looks like this when we're dealing with numbers. We're going to subtract 2 from both sides of an equal sign, and 8, of course, is equal to 8. And that's what I'm left with after I take off 2. Now, there's also the property of inequality, which seems to be the same thing, but there is one big difference that we're going to deal with. But for subtraction, it's very similar. If I take two shovelfuls of sand from this pile and take two shovelfuls of sand from this pile, I'm subtracting 2 from both sides. And this small pile is even smaller, and the big pile is smaller, but it's still larger by the same amount. In other words, if I subtract 2 from both sides, I have 1 is less than 8. And it's still true even by the same amount. The original pile was 7 shovelfuls larger than the small pile, and it still is. So that didn't change. This is called the subtraction property of inequality. Now what we're going to do is the same thing, except this time, instead of subtracting, this time we're going to add. So if I add 3 shovelfuls of sand to this side and add 3 shovelfuls of sand to this side, the two piles are going to stay equal. I can add 3 to both sides. And that is, you guessed it, the addition property of equality. The subtraction property of equality also works. And here's where we get a little bit interesting. If I take 3 shovelfuls of sand from this side, if I add 3 shovelfuls of sand to this side and add 3 shovelfuls of sand to this side, I'm going to add 3 to this side, I'm going to add 3 to this side, and I now have 11 is greater than 4. And it's still larger by 7 shovelfuls of sand. That is the addition property of inequality. All of this works the same way that we expect it to. Now, it gets a little more interesting when we have to double it. So this time we're going to double the amount of sand on both sides. Now I have 6 shovelfuls of sand on each side, and I have two big piles of sand. Each one has 6 piles in there. And what I'm going to do is I'm going to double this side, and I'm going to double this side. And they're still equal, aren't they? See that? On this one, I have, and if I double this side, I'm multiplying by 2. This is the multiplication property of equality, and it's still true. Now, if I double this one, sorry, it's a little overlap there, and I double this one, we can see that this side is even double as large as this side. In other words, we just doubled the difference. These had a difference of 4, and now I have 12. Why did I write that way? I miss Baz. Sorry, guys. I kept on reversing my inequality. I was wondering what happened there. I had 6. Spaz is greater than 2. Sorry. I think I had 2 there. And when I double this side, 2, and double this side, I have 12 is greater than 4. And what I want to point out is that the difference between the 2 and 6 was 4, but now the difference is doubled. It's 8, but it's still smaller. The 4 is still smaller than the 12, and that would be true if I tripled it. Look, even if I made it triple, I would have a huge pile over here. I would have 18 shovelfuls over here. And over here, I would only have 6. Do one more. Now this time we're going to divide it up. So what I'm going to do is I'm going to divide this into 3 equal parts, and I'll divide it as evenly as I can. There's 1, 2, 3. So I'm going to divide it into 3 equal parts, and I'm just going to take this little piece right here. And if I had 9 before, and I divide this side into 3, and just take that little piece, if I divide by 3 on both sides, hopefully everybody can see that 3 is still equal to 3. And on this one, I actually have the inequality written correctly. I'm going to divide this side by 3 into 3 equal parts, and I'm going to divide this little pile into 3 equal pieces. And I'm going to take this little piece right here and compare it with this bigger piece over here. I'm dividing by 3. And of course, 1 is still less than 3. Now, what I want you to think about is what would happen. How could I represent negatives in this situation? And that's going to be our last little piece that we're going to think about for a second. Oh, there it is. How would we represent negative values? Now, what I'm going to have you do is start with 3 piles of 3 shovelfuls, and I want you to take 5 from both sides and think about what would happen. On the other side, take 5 shovelfuls from each side and see if it still works. And think about how the negatives could be represented and if the inequality is still true. So hopefully you'll get this, and sorry about the mistake. Hopefully it'll help you keep in mind that you do need to be careful when you write your inequalities. And have a nice day, and I'll see you back for the second part. Bye-bye.